In Atlantic Canada, there's an incredible new catamaran passenger ship that turns the seaway into a freeway. It's called the Cat, the fastest car ferry in North America, cruising at speeds that can reach 90 kilometers an hour. Inside, it looks and feels like a jet aircraft, but this jet has a 250-car garage and a casino. Someday, super ships like this might carry you and your car all the way to Europe and take the U.S. Marines to war. When most of us think of a car-carrying ferry, we think of a floating traffic jam, bulky, heavy, and slow. But not anymore. We're in Bar Harbor, Maine, where the Cat is about to take 500 passengers and 170 vehicles on a 200-kilometer journey across the Gulf of Maine to Yarmouth, Nova Scotia. A journey that used to take 6 hours now takes less than 3.
Before we get up there, doing about 11 knots, so just want to stay low here.
Yeah.
Roger that.
On this ferry, you sit on leather-trimmed seats that recline, like aircraft seats. A TV monitor tells you there's a life jacket under your seat, just like on an airplane.
Don life jacket by placing yoke over your head. Connect the Velcro strips. Pass that. Pull the securing tape as necessary to, and the alarm system will be given.
And up on the bridge, 4 stories above the water,
So 9 3/4.
a crew looking more like air crew than saltwater sailors.
Okay, ready to go on your end, Chief?
All set on my end.
Ken? Okay, let's start it up.
Coming up on the speed.
I'm the captain on board the Cat. Okay. The big thing that everyone's amazed at with this type of craft is the size of the wheel. And here's basically my ship's wheel. It's 60 millimeters in circumference, and you can operate it with your finger.
Tell them they'll see Maui fishing boat here on port side too.
Captain Bruce Harrigan had to go all the way to Tasmania, an island off the coast of Australia, where the Cat was designed and built in order to get a license to fly this ocean-going rocket ship.
We spent approximately 21 days with the builder and safety people going through systems, coming up to speed to handle, the high-speed craft.
Reaching the open sea, the captain calls up maximum power. In less than a minute, the ferry is cruising at more than 42 knots. With 1 knot equal to 1.8 kilometers, that's more than 75 kilometers an hour. Maximum speed is over 90 kilometers an hour.
Last year at the same time, I was towing an oil rig from Prudhoe Bay to Soviet-Sagavin in Russia, and our average speed was 3.5 knots. So to go from 3.5 knots to 42, 44 knots, it's quite a rush.
Moving a 750-ton vessel that's 91 meters long at 90 kilometers an hour takes a lot of power and a propulsion system that simply blows people away. The Cat gets its power, 38,000 horsepower, from 4 engines, 2 in each of the catamaran hulls. Each hull has 1 engineering technician. But the chief engineer does his job entirely from the bridge.
It's basically done through this mouse. I can bring up what I want. I can start the engine from here, stop it from here, put it on and off the switchboard. These buttons here are for the closed circuit TV. On my left we have all the machinery spaces. I can freeze this at any point in the event that I wanted to monitor one of the particular machinery spaces, or I can hit this button, which will go on auto run and show me a different shot every 2 seconds. If there should be a problem, I can just hit this button and the engine will stop straight away.
And 3 cables to the wheel.
3 to the wheel.
Fuel consumption on this ship at full speed is approximately 5,000 liters per hour. So, for example, on the left screen, if I wanted to see how much fuel we have on board, I could bring up the fuel tanks, and it gives me my fuel in liters, tons, cubic meters, and so on. We also have long-range tanks, which we use on our delivery voyages, as when we brought her up from Australia. These have a carrying capacity of slightly over 200,000 liters apiece.
The voyage from Australia took 14 days on a route that went across the Pacific, through the Panama Canal, and up the east coast of North America. More than 20,000 kilometers in all, at an average speed of 45 kilometers an hour. With planned stops in Tahiti and Panama, the voyage took 20 days in total. The secret behind the speed is not purely engine power. It's also the design of the twin catamaran hulls. As the Cat surges forward, it gets up on a plane, just as if it was towing a water skier. The stern comes up, reducing drag and adding more speed.
I have 4 levers, 1 for each engine, which allows me to control the amount of revolutions that I put onto the engines.
At the end of each hull, 19,000 horsepower spins a jet shaft. This shaft, in turn, is driving a mighty 6-bladed fan. Water is scooped up through openings underneath the Cat and forced into the spinning fan. From there, it's blasted out through much smaller openings called water jets.
The water is forced aft through a 5-foot opening, which reduces down in size to approximately just over 2.5 feet on the output side.
Water passing through a tube which narrows down will exit the tube faster than it entered the tube. Like a balloon blasting off at a birthday party. The jets have another purpose beside pushing the Cat at breakneck speed. They're also used instead of a rudder to turn the ship. In fact, the water jets will turn the Cat so sharply, anyone not wearing a seatbelt would risk serious injury.
Where these crafts are so maneuverable, I have to watch that I don't exceed a certain degree of rate per minute on a turn, because I wouldn't want to knock a passenger off his feet.
The amount of water is amazing that travels through the 4 jets. It equals 72 ton of water per second approximately, which is 18,000 liters per jet per second.
That's approximately 80,000 cans of beer per second.
Flat out, the Cat roars into the Gulf of Maine, where it will encounter huge tides, fast-moving currents, and big rolling waves. Together, they produce all the terrors that pitch, roll, and heave are famous for. Just waiting to turn the 500 passengers into staggering seasick zombies. But the Cat has an answer for that. Whenever waves in the Gulf of Maine approach the 3-meter mark, North America's fastest catamaran car ferry can almost guarantee smooth sailing. The engineer simply activates a unique computer program. a ride control system which seems to anticipate the ship's motion and immediately calms the rolling, pitching, and heaving. This really is where the airplane in the Cat comes to the surface. Well, actually it goes beneath the surface, acting just like the tail section on a jet aircraft. The 12-ton T-foil is lowered from underneath the main hull when waves are getting up around 3 meters high. To reduce rolling motion, the Cat uses large trim tabs, like the ailerons you see on airplane wings. These are located at the stern, and by acting together, one pushing up while the other pushes down, they steady the Cat as it begins to roll.
Here to my right is what we call the ride control system. It's controlled from this small computer here, which I can set the parameters on depending on the sea state. We have a T-foil deploy control here, as well as a trim tab control located below it. This can dampen the movement of the vessel in rough seas and add to passenger comfort.
Another breakthrough in passenger comfort was a modification to the twin catamaran hulls, a special wave-piercing shape to cut through waves instead of bouncing over them. There's another reason the passengers don't suffer much in the way of motion sickness. Although they're on a voyage of nearly 200 kilometers, they don't have to spend much time at sea.
We're making the trip here in less than 3 hours. On a conventional vessel, we would be over 6 hours. And time is a factor for motion sickness.
Every day, thousands of Canadians and millions of travelers and commuters around the globe rely on ferries of every imaginable size and shape. From Tasmania to the Irish Sea, from Newfoundland to Vancouver Island, they form an essential part of the world's transportation network. But the bigger they come, the slower they go, on the water and in port. It's all about balancing size, speed, and economics. The quest to build faster and faster ferries has led to many innovative designs over the years, and just as many dead ends. In the 1970s, Robert Clifford, a ferry owner in Hobart, Tasmania, went looking for a faster ferry design.
Well, the original thought process revolved around a hovercraft, which was a vessel that is supported by a column of air. That column of air cuts the wetted surface and friction down quite a lot. But unfortunately, having a square shape, it's a very, very difficult shape to drive across the water.
Hydrofoils similarly. They rely on underwater surfaces to lift the hull out of the water for frictionless flight. But the bigger a hydrofoil ferry is, the heavier it has to be, and the harder it is to lift. And when a hydrofoil reaches a velocity of about 60 kilometers an hour, the laws of physics kick in, dragging the planing surfaces down. A heavyweight catamaran doesn't drag at high speeds. In fact, friction seems to diminish the faster it goes. The Aussie's first prototype hit the water in 1977, a propeller-driven steel ship that could carry 150 passengers at nearly 50 kilometers an hour. The next step was to maximize the concept, to rev up both carrying capacity and speed. It seemed like a great idea. especially when the engineers figured out that if they could build their giant cat out of lighter materials, it could carry even more payload using the same amount of power. And then one day, pondering the problem over a cold tinny, inspiration struck. When Australian designers set out to construct the world's fastest car-carrying ferries and sell them to countries as far away as Canada, they were inspired by an object dear to their national soul, an aluminum beer can. Aluminum is only 1/3 as heavy as steel, so building a ship with aluminum could eliminate the weight problem. It was a concept that just might work if the engineering principles that make a six-pack strong enough for a man to stand on could be adapted to a 750-ton wave runner.
The stage of technology in the world today in aluminium construction is such that it is an extremely reliable material.
Robert Clifford and his team made the calculations. Using aluminum beams instead of steel and welding aluminum panels for the hull and superstructure could cut 500 tons off the ship's weight, with no loss in strength or safety.
So a ship that weighs 1,000 ton of construction tons, effectively in aluminium is only going to be 500 tons. That 500 tons goes straight to the payload.
But there was another hurdle. No one had ever tried to assemble such a huge aluminum ship before.
A typical shipyard anywhere in the world is actually not very well trained in aluminium construction, and that's something that all shipyards around the world have some trouble coming to grips with.
Aluminum welding requires specialized training, and the welds must be performed hot and fast, using more electricity than regular welding, and moving faster along the seam.
Our best tradesmen have probably been training for 6 or 7 years before they're proficient at getting the best out of the material.
The only people with that kind of experience were building airplanes.
It's more akin to building aircraft than it is to building ships. 747s are built out of it, for example.
On completion, the Cat weighed in at just over 300 tons, or 32 million beer cans. It was 91 meters long, 26 meters wide, and had an incredible rate of speed resulting from a combination of three things: its lightweight construction, slender wave-piercing hulls, and a powerful water jet propulsion system. Less than 3 hours out of Bar Harbor, Maine, the Cat arrives in Yarmouth, Nova Scotia. Entering the harbor, it slows to 12 knots so it won't create any big waves. Waves that could easily swamp a small boat. The town of Yarmouth has been home to an international ferry service for more than a century. The trip to Bar Harbor by land would take more than 10 hours. The conventional ferry on this route reduced that trip to 6 hours. The Cat makes the trip in less than 3. The decision to introduce North Americans to fast ferry service was made by Bay Ferry's president, Mitchell McLean.
Well, there are a number of builders in the world, but I had received an awful lot of information from a chap called Robert Clifford of InCat from Hobart, Tasmania. And Robert became a friend and used to drop in and see me 3 or 4 times a year. So, quite frankly, I told Robert I don't have enough money to buy a ship. And he said, Mitch, if you want a ship, you'll get a ship. And so we went about raising the money, and through various means we were successful, and I'm quite pleased that we did. We doubled our business in the first year, and we've added to that increase every year we've been in business. On this ship, in 14 hours, we do, in effect, 2 return trips or 4 legs of a voyage. Therefore, your revenue goes up, and your cost of labor and all the fixed costs remain the same. The only difference is the cost of the fuel.
Close to $50 million in lightweight aluminum drifting towards a concrete and steel dock. One false move and the 750-ton cat could open up like a sardine can. When North America's fastest car ferry makes port, the powerful water jets that accelerate the cat to highway speeds can also be used to push it gently alongside the dock.
Okay, switching to the after console.
After console?
Yes. 5 knots.
Accepting. Oh, I got her back here too.
Docking the cat is handled from a separate control station.
Contact on stern. 1 button.
The control stick is tied into the lips, water jets, which is directed by the computer. What it does is any command that I give the stick, it configures the jets to the motion that I want the craft to move. So if I want the craft to move in a sideways motion, I'll just move the stick in that direction that I want the craft to go to. I can go ahead, I can go astern, I can go sideways. So we got thread width?
25 feet to come back. 25 feet to go. Here goes 5 feet off on the back. Okay, about 40 feet off here on the stern, about 50 on the bow.
What I use for docking are these 3 cameras that I have located back aft. Gives me a picture of the starboard quarter on this camera. This is the starboard side. And also I have the port mooring station on this one. It's good way in the hull about.
With his joystick and monitors, the captain looks like he's involved in a video game of who can park the ferry fastest. And that's not far from the truth.
I can dock the craft with either 2 engines or 4 engines by a matter of what I want to clutch in or clutch out. Okay, if they've got enough lines. It's good way in the hull about.
Okay, we're going
Can declutch, Chief?
Declutch.
And finish with engines.
Finish with engines.
There, you got her on the line.
Center console.
Center line.
Operating North America's fastest car ferry only makes sense if it's North America's fastest loading and unloading ferry as well. In order to make full use of its incredible speed, the cat has to be out on the water, not hanging around in port.
certainly the requirements, believe it or not, are mostly on shore, because what we have to be able to do is to load and unload this ship in 1 hour. We had to extend the size of our barges that held our loading ramps and widen the loading ramp so we could get 1, 2, or 3 lanes of cars off at once, or line them up properly going on board so they ended up in the right spot in the ship.
The fact that it can carry a large amount of vehicles of any shape and form, right from motorhomes right down to motorcycles. We can put any combination that we like on board.
The shape of the Cat ferry itself is a real asset at loading time. It's big and square. It was 91 meters long, 26 meters wide, just like a huge packing crate.
The Cat's a very wide vessel, and it allows you to bring cars in 2 different ways. So if I have my 2 side ramps down, I can load cars on the top and have them being parked while I'm unloading down underneath. So I can do 2 things at one time. The Cat has 9 separate decks, which I can lower and raise in any configuration that I like. That allows me to put, I can have up to 135 cars with 1 ramp down, up to 185 with 2 sets of ramps down, and up to 220 to 225 with all 9 ramps down. It basically is just like putting a crossword puzzle together. It's, you just find the pieces that you need and you put them in place.
Communication check, the headset's here. Okay, loud and clear. Starboard side. Machinery spaces. It changes to each space every few seconds. Screen on the right.
Okay, coming up on 4 buckets.
Up on 4 buckets, up on the speed. Tabs are down.
Tabs are down, thank you.
Speed 34 knots.
34, thank you, Chief.
The passengers on the Cat have lots to entertain them. Spending money, winning money, or losing money. Or just staring out the window as the ocean flashes by at 90 kilometers an hour. There's always a possibility they'll spot a whale. When high-speed ferries first started operating in the Fundy area, environmental groups were very nervous. Could a ferry traveling so fast avoid whales and other marine animals? Could a whale get out of the way in time if it spotted the Cat hurtling towards it? And what would happen on board if the Cat smashed into a whale?
Okay, we got 2 fishing boats up here on the starboard side, Cap. 1.5 miles. That's the closest guy there, and the other guy's 2 miles.
Goodbye, Ford. Roger.
I got another Cap.
There are lots of hazards here on the Bay of Fundy. When 750 tons of metal, fuel, and flesh are flying through the mist at superhighway speed,
Coming to start. 128.
fog is a constant menace, and so are slow-moving cargo ships, tiny fishing boats, even whales.
And that's 5, 6.
Of course, there are lots of days when nobody sees anything out here. Days when the pea soup fog rolls across the bay.
We could have 2 weeks at a time here that you wouldn't be able to see the water due to fog.
If you can't see the water, then you can't see the whales, or the fishermen, or the 200-meter-long steel monsters called oil tankers that also prowl the bay.
It's burn.
002.
Coming to 2.
But everything that's afloat in these waters can be spotted and tracked by one of the world's best radar platforms.
Here, just came around the fog.
Full buckets.
Full buckets.
A combination of X-band and S-band radar. S-band is for close-in work, and X-band is for distant targets out on the open sea. Captain and navigator each have a screen.
Well, we work as a team where I provide the information to him on the range of the target, the course of the target, the speed of the target, his closest point of approach, and the time of the closest point of approach to that target.
7-8.
7-8.
3-4.
3-4. I've got the pilot boat just coming off the cruise ship inbound there too. How's everything looking, Chief?
Everything's fine on this end.
Security, security, security. All stations, fast ready to the cat.
1.2 to the
Frisbee beam.
1.2 to the wheel, thank you.
Course will be 1.2.
New course to port, 112 on your mark.
Ships have been using radar for over half a century, and the basic principle hasn't changed. It involves an electromagnetic pulse sent out from a rotating antenna. The pulse travels through the atmosphere until it hits something, wood or metal, or flesh and blood. And it's this reflection that becomes a blip or target on the radar screen.
Well, with this radar, we can track up to 40 targets. And so you can get all kinds of information. I can switch from the S-band to the X-band, which is a slave off of the captain's radar. But the S-band is my main radar, which is good for really close-up work, for harbor work. Coming into the harbor, you want a clear, crisp picture of the harbor coming in. All the buoys, any small targets, any kayakers, any rowboaters, people in small skiffs without any really good radar reflectors on, this radar will pick them up.
To provide evidence of whale sightings and to keep track of whales over several years, the CAT often carries a marine biologist on the crew deck.
The biggest concern from environmental groups was the North Atlantic right whale, which is the most endangered large whale in the world. There are between 300 and 350 left in the world. And the leading cause of mortality for these whales are human-caused activities, ship strikes, and entanglements in fishing gear. So there was concern that these whales, with the vessel at this speed, would be vulnerable to ship strikes in this area. This particular design has a lot of good qualities. The number one thing is that it has a very shallow draft, and that, that's about 10 feet. A large animal like a finback that's 80 feet long doesn't have very far to go to get out of the way of the boat. Another good thing about the design of this is we do not have propellers. Now that's a big hazard to marine animals. If you have a near miss, the animal often gets sucked under the hull and is cut up by the propellers. Well, they don't have that problem with this boat. Right now it's put in a database. I have now 5 summers of working on this, a huge database.
Ever since Bay Ferries began its CAT service in 1998, there is no evidence to suggest that the ship has ever hit anything with flippers.
I haven't seen anything out here that makes me think the whales are doing something different than they would be if we weren't around.
Knowing where everyone else is one thing. Finding out where you are is something else again.
2 cables, got them visual. That's 152. Basically what we have is our course line going across the chart, and we have the icon of the vessel going across the chart as well. The position is updated every second by means of satellite, which gives me a real-time position of where I'm at, not where I've been.
With the GPS engaged, the captain can wrestle with the ship's helm or turn the job of steering over to the autopilot.
So basically what the autopilot does is it steers the craft in a straight line. So we plug a course in, turn it on, and it'll take over the steering duties of the craft.
The blip on the radar screen appears to be a cruise ship. Now there's an invitation to disaster.
Starboard 349 on your mark. I've got 3 targets are just northeast of number 7 over there again.
Okay, Brian. Okay, Chief, going good.
With its speed, maneuverability, and its ability to target and track anything in its path, the CAT is unlikely to come to grief.
Starboard 081 on your mark.
But if misfortune did strike, the CAT has an answer.
In an emergency, we have equipment that is perfectly capable of putting 900 people into the life rafts in 17 minutes. No other commercial ship can do anything like that.
The craft is fitted with 10 100-person life rafts.
This is how we get people off the ship if there's an emergency.
You go down a slide directly into the life raft, which is a very safe and efficient means of escape.
The slide deploys and then the raft is connected to it. Each raft can hold 100 passengers, so we can have 200 passengers out of this one slide area.
Passengers toboggan down the slide into the raft, but the CAT has to be stopped before anyone can be offloaded.
We can do a full speed crash stop from 47 knots to 0 stop in less than 600 meters.
Providing the stopping power are the amazing water jets. Turned full astern, the jets can jerk the CAT back from cruise speed to a dead stop in just 6 times its own length. Amazing, but so is everything else about high-speed catamarans. Today and in the immediate future. The beauty of the wave-piercing catamaran is its ability to go faster as it increases in size. Before long, we will see catamarans doing a lot more than ferry cars across bays and rivers. They'll begin to handle assignments on the oceans of the world.
As the vessel gets larger, its sea state capability gets considerably better. The vessel, when it's operating at 40 knots, can go through up to a 3-metre sea without serious movement. The larger ships are very, very seaworthy boats. Almost every week there's an ocean being crossed by one of our ships around the world. I think this design is going to go onward from here. It is not the end of the road by any means. The ships will get larger, they will get more diversified in their uses. Navy, Army have serious uses for these ships in various modes.
Just how serious became evident a few hours after Operation Freedom Iraq began. U.S. Marines took an experimental wave-piercing cat into the shallow waters near the Iraqi port of Qasr. In one of the first raids of the war, this catamaran with its remarkable 12-foot draft glided in and deployed a commando team to capture 2 offshore oil terminals. Other uses for the cat are a lot more mundane, like the inquiry Mitchell McLean received from a garbage company working a route from Miami to Key West.
Now, it's hard for you to believe, but that's a 2-lane road down there, and we had an inquiry from the garbage company. Believe it or not, the garbage company would pay us to run a fast ferry to get their trucks back up. So it's that type of thing. I mean, I think that the opportunities are unlimited if you really are commercial and want to look for them.
The cat and its sister ships have already made many transatlantic and trans-Pacific crossings and have picked up several world speed records in the process. And now designers are looking beyond the car and passenger business to a new breed of multi-hulled vessels which are designed to compete with single-hulled freighters. But while the designers dream of the future, today's passengers relax and enjoy the cruise. After all, they're riding on the one cat that loves to get wet. In the space of a long afternoon, the cat has made a voyage from the United States across the Gulf of Maine to Canada and back again. More than 1,000 people have been wined and dined, diverted and delivered. Their cars, campers and motorbikes have traveled with them, and all as smoothly as taking to the open highway.
Okay, secure, thank you.
The latest accumulation of salt spray is washed away as the cat makes for the dock.
255.
Overnight, a new kind of crew will take over. A crew of maintenance and provisioning people who will top up the fuel tanks, stock up the ship's stores of food and refreshments, and prep the ship for tomorrow's high-speed adventures.
Personally, I would say the future of this technology, we're just on the brink of it now. In years to come, I think this will be considered slow transportation. In years to come, I think we'll be looking probably at the 70 to 80 knot range, probably quite quickly. Time is money. People want to move quick.
It was never affected the